Hello guys, welcome to the C++ tutorial series. In this video, we will learn about templates in C++. My name is Kafu and welcome to my channel mod.dev. Please subscribe and like to help the channel grow and turn on the bell notification icon to get notified whenever I release a content on the channel. With that said, let's begin. Templates is a feature that helps support generic programming in C++. Generic programming simply means we can define a function and a class without worrying about what data types it accepts. So in order to declare a template in C++, you write a template keyword, and then in angle brackets, you write type name, and then the template placeholder, or the data type placeholder. So over here, this T here is what we refer to as what? It stands for the type name or the placeholder. So this T here can be an integer, or it can be a character data type, it can be a boolean data type, just to mention a few. So we use T as a placeholder for the data type that we want the function to either return or to take as what? A parameter. So I can just go ahead. Let's talk about function templates. So since I've declared the template, so under the template, I can just write a function, let's say with the return type of void. Let me just give it my function. And then in parentheses, the parameter list I want to take it should be of the data type of T, and then let's say this should be what? Param. That's the name of my parameter. And then the function body, I'll just std cout. Let me just see out the parameter is, and then the param that we've passed to it. Then I'll just print this on a new line. I'll just print a new line and save. So what I've done is, first I declare what? A template, and I'm saying the type name should be of what? T. So this is just a placeholder for what? A data type. And then I'm just declaring a function called my function with the return type of void. So I can even change the return type of this function to what? T. So this function will return what? A dynamic what? A data type, or anything that we are returning for this function. It will be cool with it. So when I go ahead and let's say I'll just return, when I write return whatever parameter has been passed to it. Let me just do this. Whatever parameter has been passed to it, you see we are good to go. So we can still do that as well. So but just that for this example, I'll use void and then print whatever parameter has been what? Sent to the function call argument. So I can go ahead and then call my function. Let me just go ahead in my main function. I'll write my function. Let me write this manually. I shouldn't use auto completion. Then in angle braces or in angle brackets, we write in the data type we want to return from the function call. Then I'll pass in the value of 1, 2, 3 and then terminate the line. So this is how we call functions with what? Templates that have been declared with what? A template. First you declare the template and pass in a placeholder for the data type, and then you define your function, and then you implement your code or your function code. Then when in calling the function, you provide in what? The data type you want the function to accept as what? An argument. So I can still call this function and then say the return type should be what? A double. I'll just write a random double over here, and then pass in angle brackets, pass in double. I can still call this function called my function. Let me just terminate this first. So my function, and say the return type should be a character, and then I'll just pass in a character here as the data type. And when I go ahead and run my code, let's see what we get. Good. So we get the parameter is 123, the parameter is 123.345, and then finally the parameter is what? C. So this is what we mean by what? Generic, or this is what we refer to as what? A generic function in C++. So when I go, let me go ahead, copy this function and then paste it down here. I can say let the return type should be unknown, or it can return any data type. Then finally I'll just comment these ones out. I have to return, let me comment out this one and then return the parameter and save. So when I go ahead, run my code, we get what? you don't get anything in the console. Let me see if well, we are not seeing anything in the console because I forgot to catch that value. So I'll just say int and say result, and then set it to the function call, and then finally I'll just std. I always forget to catch these values when I'm returning something. You should not do that. Std cout, let me use the scope, the resolution operator here, the result. And then when I run my code now, finally, or hopefully, we get to the result that has been returned. So you can see 1 2 3 in the console. So that is how we can make a function generate. Now one thing we can do also is we can make this template. Let me just copy it and bring it down here, and then comment this one out as well, so that we can see this here. So we can add any number of template types you want to add. So I can go ahead and add another one and say this one should be of u. So I can call this, when I call this function, let me just make it void again, call this function, I can pass in another one, the template name of u, and say another param, and over here I'll just comment this one out and comment this one in and copy. Let me just copy this quickly and then put it here, and then print another param out here. So what we've done is what? Let me just comment this one out, and then finally this one too. There were a lot of comments out here. So what we just did was what? We have declared another template type name. So this one is T and then this one is U, and you normally see this T and U used frequently in a lot of code bases. So this one is saying that what? We can provide a template type of any data type, let's say an integer, and then of another data type, let's say what? A double. So when I go ahead and then call my function, write my function in angle brackets, I will say this should be an integer, and then this one should be what? A double. And then go ahead and provide the values. Let me see a random value over here, and then terminate my function, and then we are good to go. When I run my code, we see the values outputted in the console for us. We can go ahead, let me write it again, and then say this one should be a character, then this one should be what? A boolean. So a character of, let's say, C, and then a boolean of, let's say, true, and true will result to what? 1. So hopefully we get what? The value C and then 1. So we know that true is 1. When I pass in false here, it will give me what? 0 as what? A number. So that is it, or an integer. So that is it about templates or function templates. The next thing I want us to talk about is class templates. So we can create class templates, which are classes that have data members of any data type, member functions, and member functions argument of what? Any data type. So let me just go ahead and comment out the whole of this code, and then this one as well. We have a lot of commented out codes here. Then I'll just declare a template and say type name should be of T again. Then I will go ahead and then define my class. I'll give it a name of shape, and then here I can declare 2 variables of varying data type. So, and say this one should also be of what? A length, and then define a constructor. I'll just initialize the constructor over here, and then say you should take in initialize it with what? Let's say width value, and then comma, and say length value, and then initialize them here using what? List initialization. This one will be the width value. You should know this by now if you have taken the classes video. I'm going fast here, and over here I'll just std cout and say what? Constructor invoked, and then terminate it. I'll put that on another line, and then save my code. So I've just defined the constructor over here. I can go ahead and then define a function. Let's say a function of print values of the return type of void, and then over here I'll just std c out and say what, and print out the values width and then the value length, and save my code. And now what I did was I created a class template, and I declared the variable, the data members. First of all, let me make this public. Other than that, we can't access them. So everything that goes under this public access specifier will be what? Public. Now you know that if you don't do it, it will be private by default in C++. So I can go ahead. Let me just come there here, and then instantiate this class and say shape, and then the name of the object, I'll just say shape1. Initialize it to 2 integers and say 12, and then to 30. Now this in angle brackets over here, I can put in what? The data type I'm passing to what? This object, or I want this object to receive. So I'm saying it should take an integer. I can go ahead and then in angle braces I can say double. This should be a double, and then let's say shape2, create another instance of it, and then pass in a random double. Then we are good to go. So I can come here and say shape1 dot, let me just call the print values method, and when I run my code, hopefully we see the value, we see constructor invoke. We know that whenever we create an instance of an object or of a class, the constructor will be what? Called for us by default, and then finally we get our result in the what? Console. So this is how we can declare we can declare a template for a class, and we can go ahead and declare that a template for what? A class member function. So I can say this one should have a return type of T. I'll just declare it over here. Just a minute. I'll just declare it over here and then terminate it, and then come out of the class and say it's having write the name of the class shape. First of all, I have to declare the template. Sorry, I'll just declare the template and then put the name over here and say type name, and then put T here. Then I'll say the function should have a return type of any data type we pass through it. Then the shape, then using the scope isolation operator, I can access the function, and then I'll just put in the function implementation over here. So I'll say function body here, and then you can put in whatever you want to be what? Executed in this function. So this is how we can declare a template for what? A function that is part of what? A class or a method, or we can refer to it as what? A data or a member function. So that is it for template in C++. Please, if you have any question, put them in the comment section, and then that is it. Thank you for watching, and then see you in the next one.